Hello class, today we are going to talk about Fibonacci bunnies. Now, what am I talking about? Well, this is a problem that Fibonacci solved. It's a word problem. It starts off with some very simple rules. Rule 1, bunnies never die. Very important rule. And 2 is baby bunnies mature in 1 year, and mature bunnies or mature pairs of bunnies make one pair of baby bunnies each year. So those are 3 rules. So here's the question. If we start off with 1 pair of baby bunnies in year 1, how many bunnies will we have in year n? So this is what we're going to try and solve. Now, in order to do this, let's use this symbol. And because the computer screen I'm writing on is kind of small, I'm going to use that symbol to represent 1 pair of bunnies. Not 1 bunny, but each time you see this, that stands for 1 pair of bunnies. Okay. Well, let's try to think about this. In year 1, I have 1 pair of bunnies, and they're baby bunnies. In year 2, well, now those bunnies are mature, so I still have 1 pair of bunnies. Now the thing is those mature bunnies are going to live into the next year because bunnies never die. But since they're mature, they also make 1 pair of bunnies. Now the pair on the right is going to be a pair of baby bunnies, and the pair on the left is going to be a pair of mature bunnies. So let's think about this. Well, we have the bunnies from the previous year. Now these are both going to be mature because we're now moving into year 4. But the mature bunnies from year 3 are also going to produce another pair. So we have, I'll draw a little line right here to show you guys. So the bunnies to the right of those lines, those are all babies. What happens in year 5? Let's see if we can figure this out. Well, all the bunnies from year 4 are going to live. And they're all going to be mature. And then, all the bunnies from year 3, well, they were mature in year 4. So because of that, and those are these 2 bunnies on the left side of that line in year 4, because of that, I'm going to get 2 pairs of baby bunnies in year 5. Now in year 6, I get 1 pair, you start writing these a little smaller, for every pair that was around in year 5. And that's the mature bunnies. But the baby bunnies in year 6 are going to be equal to the total number of bunnies from year 4. That's 2 years behind, because all the bunnies that were around in year 4 are now mature in year 5, so they're ready to produce babies in year 6. So what I get is I get 3 pairs here. So let's think about this. This is 1, this is 1, this is 2, this is 3, this is 5, and this is 5, 6, 7, 8. Now, if only there were a way to do this in general. If only there was some pattern we can see. Well, we can see the pattern. You see, if we think about this, just like we did it for year 6, in year 7, the total number of bunnies is going to be the number of bunnies that were alive in year 6, because they don't die, and they're all going to be mature, plus the number of new births. And the number of new births is going to come from the number of bunnies in year 5, because all the bunnies that were around in year 5, well, they're now mature by year 6 and ready to give or create new bunnies to our bunny world in year 7. So, well, I have all the bunnies from year 6, so that's 1, 2, 3, 4, 5, 6, 7, 8, plus the 5. From year 5. So this is 8 plus 5, or 13. So in general, the number of bunnies that we have in year n plus 2, so let's use Fn for the number of bunnies in year n, well, that's going to be the number of bunnies we have in year n plus 1 plus the number of bunnies we have in year n. This here represents the bunnies that live into the next year. This here represents the new births. So, I mean, there are a few ways we can write this. Sometimes it's also written, if you want the number of bunnies in year n equals, you could write it like this, as long as it's the number of bunnies from the 2 years before. And that's the way we wrote it. Before. So either of these formulas together with F1 equals 1 and F1, or F2, sorry, equals 1. So if you combine either of these two rules with this, you can find the number of bunnies in any given year. For example, just going through again, year 1, well, was 1. Year 2 was 1 in terms of the number of bunnies. Year 3 is going to be 1 plus 1, which is equal to 2. Year 4 is going to be, well, year 2 plus year 3. So that's going to be 1 plus 2, or 3. Year 5, we already computed these, so you could check them against what we've done before, is 3 plus 2, or 5. Then year 6 is 5 plus 3, which is 8. And we can keep going much faster now than drawing the pictures of each of the bunnies. This is going to be 8 plus 5, which is 13. And we can keep going easily. F8 is going to be 13 plus 8, which is 21. Year 9 is going to be 21 plus 13 is 34. Now, what are the use of these numbers? Well, these numbers have all sorts of uses. As a matter of fact, they occur naturally in a lot of, well, in pineapples, other fruits, other structures that, well, for instance, if you look at the sides of a pineapple, I guess you could call them the scales of the pineapple. You measure the sizes, they correspond up to the Fibonacci numbers. But it also has lots of applications when it comes to growth, things that are growing. You guys probably know, hopefully you guys know about exponential growth, things that grow at the rate a times b to the x. Well, this is a slightly different measure of growth. And it is possible to come up with an explicit formula for these that don't involve this sort of recursive rule that you get here. It's possible to show all sorts of interesting properties. For example, notice we have an even, an odd, an odd, an even, an odd, an odd, an even. Well, the next two are going to be odd. That's interesting and easy to prove. There are properties about the sum of the first n Fibonacci numbers, of the sum of the first k Fibonacci numbers. And there's actually a journal. There's so many different interesting open problems with the Fibonacci numbers that there's been a journal. I believe it's 3 times, maybe twice or 3 times a year, maybe 4. But they release new results about these numbers every year. There are people that are still finding new things about these numbers, new properties. So these numbers are very important for all of mathematics. And they are credited to Fibonacci from this section, a great mathematician.